is Gintvilė Šimkonienė. I'm from Kaunas University of Technology, from Lithuania. So we are collaborated with Malta Energy Research Group, and we wrote energy and CO2 abatement cost potential in Maltese household. So the main aim to evaluate case scenarios studied energy saving techniques in Malta, including lightning and low voltage appliance, wind turbines, solar photovoltaics, and energy storage. So to develop the first techno-economic design study for this properly, because it haven't been did and also Lithuania, we haven't found this kind of research to examine the retrofitting system in a case study of multiple legislation and building stock, to support the reduction of carbon emission by improving Malta's housing supply using renewable and alternative energy source and high efficiency appliances in Malta, including solar photovoltaic, wind energy, and chemical energy storage initiative. So during directives and rules of Malta and also renewable directives, also European Commissions need to reduce pollution from power plants and reduce electric energy useful, but nowadays we see that all electrical devices and all houses are useful, also houses, also cars. We are becoming dependent from electric energy and its sources. Around 30% of Malta's CO2 emissions come from its inhabited homes. 70,000 are uninhabited, 3/4 of inhabited dwellings will still be in use, and the building stocks, especially the housing sectors, would need to provide significant savings by implementing effectiveness energy saving measures and part of this overall aim. So over 27% carbon dioxide emission come from the homes, according to the WWF. More efficient dwelling stock with a cut carbon dioxide emissions. This regulation applied to new and refurbished structures. So was taken climate data and different kind of plants which are producing electric energy, and unit system cost assumed to have 1% maintenance rate on the capital cost and lifetime for 25 years. So techno-economic framework was used to first of all to system performance and degradation. Life cycle energy was useful, and energy cost, system cost, and life cycle cost. So system degradation is the devices efficiently costing demands the system net present value based on abated or generated life cycle energy calculation, and the residential energy rates, lifetime, and funding techniques determine net present value. So the imagined abatement cost per kilogram CO2 equivalent was calculating when the peak values. You can see that here insulation, lightning, apparatus, solar photovoltaics, and so on. When the peak values when using all kind of devices at homes can be making the bigger amount of electric energy useful, and at the same time how CO2 can be caused potential electric energy reduction or generation if quick action is done. Each bars behind is the avoided kilowatts cost in euro. So here is showing insulation of the houses, how for this, it's not showing. So for this part is how electric energy can be solving and reducing for the area, and the part of this is showing the comfort zones in the winter and the summer times. So illustrate the usage of renewable energy, alternative energy sources, and high efficiency appliance in 3 stories in Malta. So many Maltas indicated how many adopt similar systems, and these most solutions are feasible as their abatement energy cost is below 0.11 kilowatt hour energy storage, and with energy may not possible now. However, location is key. In the next 25 years, energy efficiency system of photovoltaic solar might be able to more than 250 megawatt hours. This translates to 140 tons CO2 mitigation in 25 years. So this paper is the first techno-economical design study for this properly monitoring and full system approach needs for the research. So thank you for your attention.
Thank you very much. Any questions?
When you speak about energy storage, you have not looked at it. What you mean, thermal there, or do you mean chemical battery storage? You've said energy. No. At the very last conclusion.
Okay.
You said you did not look at energy storage. Energy storage, and when that may not be possible. But what energy storage were you thinking about?
About the batteries.
Batteries.
Yeah, for that moment, for this researcher.
Oh, maybe it's English. You did not have energy storage in the application.
Yeah.
Oh no, because it is possible to do energy storage.
Yes,
Okay.
Is it possible to have wind turbines?
Yes.
In the
No. The law of Malta does not allow wind turbines.
yeah, that's
No.
what I was thinking.
No, it does not allow that.
Okay.
The only wind turbines that might be allowed are going to be
the
offshore. Yes.
Yeah.
No, on land they're not allowed.
It's the same like where I come from. In Cyprus, you're not allowed to install a wind turbine in an inhabited area.
Okay.
You are allowed to install them in the mountains or overseas, in the sea,
In the sea,
etc.,
yeah.
but not inside the city. That's why I wanted to ask.
Yeah, but you can produce from offshore.
Yes, here you're saying the first part that you're talking about applies to the 3-story 1870s home, which has a footprint of 80 square meters in Malta. Yeah, the majority of those homes in other European countries are considered to be cultural, reserves, and you're not allowed to make any changes in order to, let's say, either enforce with the thermal insulation the outside of the building, etc. How did you? I don't know what the regulations are in Malta, but how did you improve this usage and you implemented the renewable and alternative energy sources without affecting this appearance of the place?
Yeah. To be clear, what to improve of the houses, you mean? Yeah.
Of the specific house, 1870s homes.
Yeah, but we are speaking to involve also in install for renewable energy, useful this energy. At this peak times when you need more electric energy.
Yes.
So we are speaking also to reducing CO2. That will be mitigation. Yeah. So.
So you're going to leave it as it is, and basically install PV somewhere else. Yes.
We are making also economical calculation. If it is more expensive to change the houses, that insulation will be the better, and the also heat and everything will go through the walls. So this project maybe can be not efficiently. So it depends from the prices at this moment, because the prices all the time is changing, and the prices for renewing the buildings and so on. So it's hard to calculate everything at this moment. After the 1 year, we'll change it directly, and they will see that it's not efficiently and not cost efficient.
I see. There was a project, I think it finished last year, the year before, and it had partners from Malta as well. I think it was called Violet. Perhaps you should have a look at it. It basically was talking about the implementation of improving the energy efficiency in buildings which are traditional and have a cultural heritage.
Yeah.
So that might be useful together with your, because as we've noticed during our stay here, Malta is full of all these beautiful old houses.
Yes.
And it will
No, she is right. Unfortunately, the prices of building materials, they are going up all the time. Because Malta as an island, the transportation costs are going up all the time, so the building material costs are going up. So it's very difficult right now to make an economic comparison of how much it will cost to put insulation. Within 1 year, the insulation might be 3 times the price.
Yeah. Well, thank you very much. Then